Okay, to write an inequality to go with this statement, we have a number x is less than 5. So there we have x is less than 5. And greater than 2. So to get the greater than 2, we would have it wrote that way. You cannot write it as one statement in this form here. It does not work that way. You need to put the x in the middle if you're going to make a combined statement. And when we put the x in the middle, we're going to have the x being greater than 2 and less than 5. So the x term is in the middle of the compound inequality. Okay, remember to solve a compound inequality, if I need to move that positive 3 to get the x by itself, I have to subtract the 3 here, on this side, and on this side. So I have to subtract the 3 in 3 places. So we subtract the 3 from all 3 places, and we're left with x is greater than 3 and less than or equal to 9. And there's our number line. Okay, to solve this inequality, once again, we're going to be dividing by -3, but we have to divide by -3 in the middle, the right side, and the left side. Now, also, since our inverse operation is to divide by a negative, we have to flip these inequality signs. These two signs are going to switch. So we have r is greater than -9 and less than or equal to 3. So that's a closed dot on 3, an open dot on -9, and we shade the area in the middle. Okay, to solve a compound inequality with an OR, it's like we have two separate equations here. We have this equation and we have this equation. Just solve each one separately. So when we solve the first equation, we add 1 to both sides, divide by your 2, and m is greater than or equal to 3. When we solve the second equation, we divide by -5. Since we're dividing by a negative, we had to take the reverse of the inequality. It changed to a less than. So then with our two equations, our graph will be closed dot on 3, open dot on -5, and we shadow the outsides, and it would be an OR. Now, remember when solving absolute value inequalities, we have to solve up to these absolute value marks before we can split up our equation. So we need to remove the +7 and the multiply by 6. And remember also, you cannot distribute a number through the absolute value marks. So the first step we want to do is subtract the 7 from both sides of the inequality. And then we need to divide by 6. Remember, 0 divided by 6 is 0. And now we're left with this part where the absolute value is greater than 0. Since the absolute value always takes the positive value of that absolute value inequality will always be true. So my solution is all real numbers.